So guys, what you saw was that Jugalbandi between Hari Prasad Chaurasia and Ustad Zakir Hussain. So I was really inspired by this, and I said, what if we change the context of this and replace music by code and replace instruments by languages? And I discussed this idea with Ryan, a friend of mine, and we met through a common friend, and he just liked the idea, and we said, you know what, why not give it a go, and why not try it out? So meet Ryan. We've been Jugalbanding for about, what, 3 months, more than 3 months now, and we know each other for more than 1.5 years. Ryan.
Hi, yes, my name is Ryan Lemmer. I'm from Cape Town, by the way, and we've been Jugalbanding across oceans. This has been an Africa-India affair. It's been great for the last few months. We've been doing this. We covered a lot more material in our Jugalbandi than we can touch today. So I hope to give you a taste of what it's about, but that's probably as much as we're going to do today. So I want to just set the expectation like that. Jugalbandi is really about learning by looking at concepts that you know from multiple aspects, multiple viewpoints. And so the first thing we wanted to do is just take a poll of what are the languages in this room. So I'm going to start by some language. When I say I know them more or less. So the first one I'll put down is Haskell. Anyone else? I know Haskell. Anyone else?
Any other languages? Your list of languages that you know. So for example, you can put down.
I'm going to put down closure also. So I'm just going to start and you join in, right?
Put Scala for me.
Scala.
Java, Groovy, Java, Groovy. Groovy. JavaScript, thank you. Nine. Go.
Good. Racket.
Racket, yeah, you could put Racket. Anybody codes in Scheme Racket?
Do you think Oscar want to take with us? These are the languages we're going to make sure that we play with. Yeah. That should do it, right? Yeah. Great. So we covered 9 what we call melodies. So themes that, these are themes that we felt coming from imperative style of programming. These are areas that are not necessarily obvious, that are actually quite important in functional programming. So we're going to start with the very first one, which is called everything is a lambda, because lambdas are the basis of functional programming. So we're going to look at what is a lambda and how it appears in all these different languages. we're going to start in using a few languages only, and then we can draw some of those languages in afterwards. So I'm going to start with a piece of closure, and I want to define a hash map. And so by that I mean I'm just going to create a coordinate, something with an XY coordinate. X value is that, and the Y value is that. Now, the interesting thing about this data structure, because this is ultimately, it's just a data structure. It's a little hash map. The interesting thing about it is I can actually, if I want to get at a key, my shortcuts weren't working. If I want to get at a key, I will do it like this. I can take the hash map and apply it to the key. So this is, just stare at that a moment and see what's going on. In closure, what this means is, this is the function that I'm applying to them. And so what is quite normally a structure in an object-oriented language becomes a function. So a hash map is not a structure, it's not an object, not made up of a class. It's actually a function.
I'll just have to kill it, and
okay.
It's kind of hung here, so.
Okay. Just the live coding was failing there. We just want to actually execute it.
Sorry about that. We just.
Is that that?
No, it's.
We should do a Mac Windows Jugalbandi also.
Okay, so let me see. There we go. Sorry about that.
So what we're quite used to being a structure, a thing, a noun, becomes a verb. This is a functional. And similarly, I can define an array like this. I'll call it nuns. And so that's called a vector enclosure. It's basically an array. And the same thing applies if I wanted to get at one of those values, if I wanted the 0th index. So if I do that, you'll see that's 1. So I can now do 0, 1, 2 to get at the innards of an array. So this is, if you were in Java, you would have said array, maybe square brackets, index. Again, this is a function that I'm applying to. So it's a small thing, but it's a big thing. So let's look at it. Let's look at it in Scala.
Okay. So I'll just go by your example here. I'm just going to grab this example, and let's look at Scala here. So in Scala as well, map is a function. Like what we have been used to seeing map as a data structure where we map keys to values. In Scala, map is a function. So I'll just say map, and M is a map. I'm just going to grab Ryan's data here where I'll say X is 11 and Y goes from 21. Yeah, and we know that if this was Java, we would have been doing map.get key, right? Or C#, we would have been using probably a subscript operator, right? But here, essentially, map is a function. So if I said this, so the way we are used to access functions, map is a function. So get me the X for that. In a similar way, a list is a function of its index. Map is a function of its key. So let's say I have a list of 1 to 3 elements, nums, that's what you call. And so what I'm going to do is I'll say nums, and instead of picking, I'll pick the first element, which should return 2 to me. So there we go. So map, same thing. Both are very identical. I don't see much of a difference. But if this was Java, you wouldn't, or you would have to write, literally an array like this, and the syntax would be, and then you would say array of 2. That would print 3.
This is one of the first oddities that you'll see entering a functional language. But let's look at lambdas now. So if I wanted to, in Clojure, define a lambda, I would do it like this. So I want to define a function that gets the square of something. It takes the square of something. And I'm going to define an anonymous function. It takes a number and it multiplies that number by itself. So this is the syntax for creating a function, an anonymous function. And I'm just giving that anonymous function then a name. So I can then apply this like this. This is a raw lambda. So I'm going to put down a function right next to that so that you can see the difference. In Clojure, you'd more likely write a function, defined function, defn, and it would be a somewhat more, really just a more compact syntax. I'm going to put it right underneath. I'm just going to line things so that you can see exactly how it differs. It's more compact than writing a lambda. And similarly, I can now go and do that. So in Clojure, a function is layered on top of a lambda. A function is just syntactic sugar on top of a lambda. So lambda is the foundation of all functions and methods in Clojure.
So in essence, lambda is an anonymous function, and you've given here the name to it, isn't it?
Yes, yes. And really, really defined function is implemented as a lambda under the hood. This is not true in all languages. So let's look at Scala. How does that work?
Sure. And before that, I just got feedback about changing the background. So I'm going to change the theme to white.
Right.
So people can see what's going on.
Solarized light, maybe.
A solarized light? Yeah, okay. Better now? Is this better? Okay. So like what Ryan showed you, that lambdas are the first-class citizens in Clojure, right? Let's look at Scala, right? So I'll just go here. So we saw this stuff here. What I'm going to do is, let's say in Scala, we define a square method, which takes in an int and returns an int. So we get 4. Yeah? This is just your square method, right? In Scala, if I did, for example, I could define a square method, or I could define a square as a lambda. This means that square is a lambda which consumes an int and produces an int. Okay? And the definition of that is now the interesting bit that you were talking about, like whether the functions are first-class citizens or not. Yes, it is, but let's try to do this here. So if I did square method, and if I wanted to see square method, if I just printed this, it's going to say missing arguments for square method. Follow this by a placeholder dash if you want to treat it as partial function. So basically, in Scala, a method is just a method. Whereas, let's see what this guy prints. Oh, I'll just comment this piece out. It says function 1. So this square is function as an object. So if I did dot get class, if I ran this, it's going to say there's some main $ anonymous class. So the underlying implementation is function as an object. So there are two differences here to take away. So a method is there, which is a square method, and then you have a lambda. Both the implementations are different. Can I convert one form to the other is the next question. So in Scala, I could pretty much put the dash because that's what we saw earlier error as well. Now, if I print this, and if you look, both of them have been converted to a function one object. So now both are functions, and you can treat them in the same fashion. Whereas that's not the case with closure. Whether you pass in a lambda or function, both things are the same. You know,
so Scala is much more. You can see the object orientation of it right away. Scala is a hybrid. It's a strong hybrid of object orientation and functional, and you can already start seeing it here. In Clojure, we didn't see that. There wasn't this concept of an object version of a function. It was just lambdas all the way. So this is something interesting that we can just keep in mind as we go through this. How much object do you see sticking through from under the floorboards?
Even in Groovy, I mean, how many of you code here in Groovy? I think, yeah. So in Groovy too, you will see this very, very evidently. Can I just take 2 minutes to show you that? So if I had a square as a method, that's that. But now I could define square, let's say, as a lambda. And the way you define lambda, this is basically closure in Groovy, yeah, which takes in a parameter n, and then I'm just doing n times n here, yeah. And if I do print line square 2, this is going to give me the same answer. But now let's go under the hoods here, yeah, and see what this is about and what this is. So it treated square, the first one, square, as a property, and it kind of looked and said, let me find the property by the name square, which doesn't exist. But if you look at 2, internally it has implemented as a closure, a block of code, this is the underlying class in Groovy as well. What do I do to convert a square to a square method to a square closure? Is I would say this dot ampersand square. Now this is the exact same conversion you'll see. Now it has returned a method closure object. So if I steal this into a variable here, sorry, yeah, and then there we go. So you see, all object-oriented languages, they kind of have a similar flavor. Just use some other operator and go. So they're trying to bend functional.
So yeah, so when you're looking at a language, it's then interesting to see what's the difference between a lambda and a function. Is there any difference? And so in Scala we saw yes, there can be a big difference. In other languages we don't. it's not necessarily a good or bad thing, but it's important to know and understand the landscape of what you're entering. So this is why we're pointing at this. Now that we have these functions, let's do something. So I'm going to map. I want to map enclosure. Yes.
So I see two differences in the two materials where signature is different, way of writing a signature.
Yes.
The advantage they use the depth. What is the exact thing that differentiates a function?
So in Scala, def is used to define a method, and def gets the difference between def and val in Scala is def will get evaluated again and again. Val will get evaluated at the time of definition once, and that's it. Pretty much over. So you could still use a def here, right there, and this lambda would still work. But we are caching in because it's an object. You want performance benefit, so you put a val there.
So the val isn't the big deal. It's the form of the lambda.
The form of the lambda is a big deal, not the val or a def at this point. Yes.
It doesn't really function.
No, it will give you lambda, exactly. So the def and val, that's the difference. Here when you put a val, you'll get a performance benefit because now you're converting a method to an object, and once and for all it's cached for you, and you're just invoking it again. So that's how object-oriented underlying implementation is. But closure, it's completely different. But if you have coded in JavaScript, right? JavaScript, what happens? It's the same thing. I mean, the function, anonymous function, and function is a lambda there. You just pass the name of the function. Very much closure-ish, not much of a difference. Sorry. Yeah.
Great. So let's map over. Let's see what map looks, because this is something we're going to be doing a lot. We're going to be processing over lists. So I have this square function. I'm just going to stick with the function now and let the lambda go. And I'm going to map this list. I'm going to say map square over, and so it's taking that function and it's moving across, iterating over every item in that collection. The lambda enclosure is exactly the same. I've now deleted my lambda, but if I map my lambda or a function, absolutely no difference. So let's see that in Scala.
Okay. So we'll attempt the same thing in Scala here. So I'm just going to get rid of all these print lines which are there. And let's say we have a list. And in list, there is a map function which takes in a lambda, which consumes a lambda, right? And it converts. So I'm going to just use square method at this point in time and run this. So that's what it's going to give me, 1, 4, and 9. But I could also replace this by lambda. I didn't use it. So that's what it is. Now you might be wondering what's happening, because the map function, if you look at the signature of the map function, it consumes a lambda basically, which goes from int to int in this case, but square method, I mean, the square lambda would fit right into it, right? But the square method would not. So what does compiler do? Compiler does exactly what we did. Converts it. This is the under the hoods conversion happening, and you will still get the same answer.
And also note that list is an object. So we say list dot map. Map is a function. It's a method on the object of list. We said list dot map. In closure, I didn't say list dot map. I said map is a function that stands on its own feet, and I apply it to a list. Here's the list.
That's the very interesting. The verb first, noun later, whereas
Yes.
here it's noun first and then the verb.
So from object-oriented point of view, one is working always with much more with nouns, things, structures, and you can see that quite nicely in Scala still. Whereas in Clojure, it's much more verb-oriented. Okay.
So
I think at this point, we must try, at this point we want to do what we just did, but let's do it for all these other languages, and hopefully we get some volunteers. So, I know that you Haskell.
we have Haskell here. If you want to show us Haskell,
Haskell Lambda, Haskell square. So Lambda. And I just also want to say, feel free to come up. It's completely safe. If it doesn't work, we're going to die. And so just go for it.
yeah.
We're going to be good.
So Command R to run and just type in Haskell.
Okay, so what was it? Square? Right?
Square, yeah.
So if we change nothing square, but no. So nothing is the function that takes it and so, yeah.
This is how just
Command?
Yeah, Command R. So just show you this was how we wrote. So we probably need a
We
main.
just need a main.
Oh,
So because
so
this
it's
is
not an
G-
evaluator.
No, not a REPL in that sense, but it's a
Oh, okay.
Main
so it's main equals yeah.
And you could do, right?
Yeah, yeah.
Yeah.
It's good, or if it's just one statement, it's good. But,
Somebody turned on the mic.
So in this I can define
and then above the main,
yeah.
you can just define. So that's square. And I think we can do print. This one.
command R.
Yeah, Command R.
Just,
No, I think I'll have to.
that's square.
Okay.
Hey, that's Haskell.
So that's a Haskell. Function. And if you haven't seen Haskell, take a look at that. It's good math. This is exactly how you write. I'll do it like this. So Haskell is incredibly succinct. It's close to mathematics. Haskell is a really, really powerful language. If it's your thing, it's a great language to learn. You have to learn it. A bit like R. Let's see what a lambda looks like.
I mean, there's no difference, right?
So this is a function. So lambda, let me show you lambda.
It's, okay, I'm just going to do this actually.
Okay. And you know, the thing is, lambda is quite rare to use, and I'm just going to put it down. I'm just going to put it down here. Yeah, go for it.
Go for it. Yeah.
So I'll just maybe I'll do that in the context of map.
Yeah.
Yeah.
Sure.
Okay.
You want?
Yeah.
Yeah.
So, but before that, this is something very interesting in
Okay.
Haskell. So you saw that I just wrote a like stupid function multiply a b is equal to a into b, and so Haskell has this thing called currying where if you pass it, if you have a function with n arguments and you pass it one argument, it doesn't give you an error. What it does is it evaluates and returns you a function which will take the rest of the arguments. Right? So if I to mull AB, I'm using a passing the argument. So this is not an error. So what this returns me is a function which will take the second argument, and once all the arguments are complete, it will actually give value. So I call multiple 4 and this will evaluate 8. So you can do this in other languages explicitly by having library functions which do partial application, but in Haskell it's built in, and that concept is called currying.
Yeah,
so
we have another melody. And okay.
Look
at, I mean, you could.
But it's a good thing you bring it up.
Yeah.
There's a whole, there's a website for the Jugalbandi that Dhaval and I do. And one of the melodies is currying. We do exactly this. We're not actually going to touch it today. I mean, this is easy to mention because it's just we have to time. But there's a melody with currying that will show you this concept in 4 or 5 minutes. So I encourage you to dig into that in your own time. You can follow the dialogue that Dhaval and I concept. But this is a very big, powerful concept.
Now to go on to map, so it's very similar to the one that you saw in Clojure. You give map as the function. The first argument is the function that you want to use to map, and the second argument is the list. So the function SQ will be applied to each element, and it will produce a new list depending on what the function returns for each element. Now in Haskell, you can substitute a named function with an anonymous function. So I can say something like lambda x. And
So now this
it's
is the
basically the same thing.
This is the lambda.
Right? So you just in Haskell, just like Clojure or JavaScript, the function name is sort of a syntactic sugar over lambdas. So if you say square x equal to x into x, internally it is implemented as a lambda. It's just that the lambda gets a name called SQ that you can refer to.
You know what? While you're showing this, I just thought if I could show some Racket as well, because there
Yeah.
the lambda is so explicit.
Right. Yeah.
Like it's on your face.
Yeah.
Does anyone get that? Right?
Has anybody? Let me just take 2 minutes to show Racket here. I'm firing up Racket here, right? And we'll do the same thing here in Racket. So I do define, let's say, square of x, which is again all these schemish, Lispish languages. They are verb first, and they are prefixed. So that's how I would define a square function. So the operator. So just to give you a flavor first. So multiply 1 and 2, right? If I run this, I'm going to get 2 here. I could say add. So the operator is over here. You can pass in n number of arguments, and you'll get that. Some right there as 10, right? So this is pretty much how all these languages work. So I'm going to take this as a starting point and say the way I define a function square. So this is square, a function which takes in a parameter x, and that's the body of the function, x times x, and I've completed the definition of the function here. Now, if I call the function here, you get 4. Now, what I'm going to do is I'm going to say square, just print in square, and look at that. It just prints right there the lambda for you. It says the underlying implementation is a lambda. Okay, now let me go ahead and define square as a lambda. So when you define square as a lambda, you have to have some symbol that maps to that particular implementation. So I just have a symbol called square now. But now I'm going to put in a lambda this time around as a body. So I'm going to say lambda of x, and the implementation is x times x. That's a lambda right there. and I'm going to say square of 2. Oh, sorry. I'm just giving some name. Now let's go and look at how this guy is implemented. If you see, same thing, right? So underlying the conversion is really, lambda is an anonymous function if you're coming from C# world. You know lambdas basically. So that's what that is, and you're giving a name to it, and that's how the underlying implementation is. Yeah, it's a Racket thing. So if you run the same piece of code in Lisp, right? So if I run this in, what I have here is, I'll just put this. Oh, you mean the actual lambda? Oh, sorry, I didn't get your question. This is in Racket. This is a Racket thing. You can actually, you can either say lambda, and that's still the same, or you could actually print a lambda there, like this. Command and the backslash. Backslash in Haskell is the same thing you choose. So like.
Really worth doing. The first time I saw Lambda, I got very excited.
I was excited too. I was excited too. I said, wow, very explicit. Cool. Does anybody want to try? You want to show JavaScript? Anybody?
You don't have to compile it. Just
Yeah, we have all TextMate we have set up, and you type in and it should work. So yeah, I'll just do a little hello. Let me say con and should, yeah. Oh yeah, you're right. So if you say log and hit tab, it should do that. And command R to run, so that should be fine.
Yeah. So this is how you typically define a function in JavaScript, but this is actually syntactic sugar for saying exactly the same, and you can just say exactly the same in JavaScript. For Mac,
Does anybody know the map API? Map, it's map.
I
Map is a map.
not.
That
This
map.
might work.
Yep. Crossing is red. Let's see. Okay, so.
Oh, hang on. We actually need to return something.
Oh, yeah. Very good.
It keeps happening when you switch from
Yeah.
Haskell to.
This all of a sudden the verbosity of a language kind of shows up in the syntax, right?
Yeah.
Hey, that's very good.
So again, look, list dot.
Yeah.
So list is an object. This is a class with a method name. Looks like Scala.
Yeah.
And so JavaScript is actually quite functional. You might have heard people say JavaScript is a functional language. That's not true, but it's functional. And it's from a high amount altitude. And this will get into trouble, but from a really high altitude, it almost looks a bit like Scala from the perspective of the mixer. Scala is much more properly articulated and properly functional. JavaScript is kind of a Wolverine version of that, but it's also got this feature that you can write. So that's why if you look at things like CoffeeScript, you can actually get a very functional looking version of those. Because JavaScript has the lambdas, it has a proper lambdas.
In fact, in CoffeeScript, you wouldn't have to write this return.
Yeah,
very
it's
similar
implicit.
Very similar to Scala or Groovy or something.
And we have a lot of Java people. I want somebody from Java to come up and write this in Java and see. Yeah.
Even if we just do pseudo,
That's fine. Is anybody going to give this a shot? Java, plain Java, Java 6. Yeah, and then I'll try attempting in Java 8. Yeah. How about that? Yes, pseudo. We don't have C# applied, but please go ahead.
we have Java.
Oh, we have a Java guy as well. Okay, cool.
So we just C# would be nice.
I'm just gonna say. Yeah, we are connected. From the Hangout, you mean? We are on the Hangout.
Maybe we need a hangout. It's on video. Oh, I see.
Oh, okay.
Was it X?
C#
Going to be a pseudo code first. So
we don't have the C# technology. I don't have Mono installed, but
that's the C# of putting those brackets below, not like Java guys. So it's generally normally what you do is return. That's what you would be doing with a so normal C# code, but with a lambda expression. What we would be doing is there's a say for example where what you do is it's x. This is the lambda expression in C#, which says x goes from x to x, and we just assign
This
it.
be one maybe here.
Pardon?
Is it one text one?
yeah, no, so
This is the return.
that's the return.
Return type. Yeah.
That's the return.
And yeah, you assign the so we have a value and result maybe, and it's just that. Before, that's how you print the result. So that's as simple as it.
So what reminds me is this particular syntax is very Scala-ish.
Yeah, it's very Scala,
Scala-ish.
yeah, especially the lambda way of putting things.
Yeah.
And it also is very much similar to what anonymous concept you explained, anonymous functions. So there are a lot of anonymous methodologies there.
So if you put the type of this would be pure method. Is there a way to convert this form to this form or vice versa?
And I'm not very sure.
Okay.
Not very sure.
Okay, that's nice. Java.
Also, interesting, everything we've seen so far.
So write your Java, and if you need help, I'm there. So CL if you do and hit tab, you'll get great. And type main and hit tab. So tab. There you go.
So this is something to take in about functional programming. Functional programming doesn't have a opinion about type. Because it does it very differently than Haskell. Very different. It does have these functional aspects. So when you go into a language, when you pick a language to write functional, if you're coming from Java, you will find the Scala typing quite easy. Whereas if you're coming from a Groovy, it would be like the difficult. consider when picking your language. Not something that actually something of this sort is you actually get the whole variety of patterns. And as well as giving that probably the strongest in terms of typing, but even technically the US way of learning because Haskell compiler can import types for you and anywhere cannot really figure out what type of
So that same kind of type inference is there in Scala as well. I think Scala can supply more things.
it's much weaker than
It's much weaker, yeah. It's not that strong.
When I teach when you work square 2, the compilers are you have to if 2.0, you would have said, you're doing a real number here. But instead of it looks at what you're getting into, I'm not solid. You get the Haskell compiler.
We don't need an
I think we need needs to know first
No, we just want to print the square output and
of map, right?
how would you?
First, save them to print it easily.
So I can show you how to do that.
Okay.
So we don't need. This is great, and what we can do here, right? Over here is somehow we'll have to write a function which we don't have, right? Because this is plain or yeah. So what happened?
It's a blurring that line between how much time.
So this is the normal Java, but now how do we write lambdas in Java, Java 6? How do we write lambdas in Java 6? Anonymous
classes.
Anonymous classes. So if I were to model this function, how would I do this? How would I do this? So typically I would come up with something like interface, right, which would say function,
Some executable.
which right now will be explicit, which goes from integer. That's the input, integer, and then I'll probably have an apply method on the function, which says I want to apply the function whatever argument is passed. Now, what I'm going to do is I'm going to really do this bit here where I'll say new, and this is what's going to be val square. It's almost as if I'm cooking lambdas here, right? Function integer, right? And now we can go ahead and provide the implementation for apply. So if you want to just go ahead. Oh,
So Lambda is heavy work
Lambda is a lot of heavy work in Java.
because it's so deeply Lambdas are secondary. It's time for it. Not many people work on Lambda. There's a newer Java.
We don't need val. We need a val. I mean, sorry about that. This is like when you switch between Scala, you need to get out of the head. But yeah, so this is function. Look at that. It's all noise, isn't it? That's all boilerplate.
In Java 7, we have like removed
Exactly.
this thing.
Exactly.
In Java 8, we have introduced lambda.
Right.
So
So
they're improving it.
yes. So I can, since he's doing Java 7, I
Java
can
6.
Java 6. I can whether Java 6 or Java 7, it's the same story. I'll then evaporate this bits around the boilerplate and show the Java 8 as well. Yeah. So you'll probably do square lambda, right? Dot apply and just pass the value. So let's try to run this. What do we get? Some sort of syntactical error. So I'm just gonna use, but that's not what that is. Syntax expected. Bracket expected. Semicolon expected. Did we forget somewhere? Oh yeah. Ah, there we go. Thank you.
Oh, it should be probably.
Ah, thank you. One more. No, this is fine. It's just that it's shouting at interface function integer, already defined type integer. Type variable integer is already defined in the interface function. So why would it say that? Can anybody help us spot this error? Because this is interface function. Integer. But yeah, don't write lambdas. You're right. Thank you.
It's not a cinematic thing. I think that's, for me, that's good enough.
Should I evaporate the code to Java 8?
Yes.
Yeah, straight away. Get rid of this because Java 8 defines this for you. Get rid of this. Instead, in Java 8, you could say n is an integer and n times n. That's how you write lambda in Java 8. So what all got evaporated was the boilerplate of creating function around it, and so on and so forth. And then it has a built-in apply method. So I'll run as Java 8 now. Okay, they don't like the type because it's already specified. Great, less noise. Thank you, Java 8. Is not expected. But yeah, to go back to your point, this is what it is. Yeah. So this is something that
Once you define the square method, for instance, lambda on parts.
Yeah, this is. Oh, I need to probably import. I'm not sure. Import. No, you're right.
Because in Java we saw that you just write a square. Right? Because functions and methods don't exist outside.
Yeah, I missed out that import.
Okay.
So it's available in the. So this is how you dissolve. So this is out of the box. This is available out of the box, just like C# now. You see, Java is making the C# way with lambdas coming into play. Yes, in a similar way, you can just pass a lambda. You can have a stream. So there is a stream function. So you could have a list, and then on that list you can call a stream dot, and then you can go on. Pretty much like your C#.
But you say stream.map.
Stream.map, and
So
then
map is a method on a file.
on a stream.
So it's interesting. It's kind of really keeping that inheritance of keeping that legacy of
Yes.
quite strongly, but cleaning up a lot.
Yes. The syntactical noise is not visible here. That's all.
So we've covered a lot. I don't know if there are enough Ruby people in the room. Let's do Ruby. Not, we can just discuss it for a second.
Do you want? Do you code? You can show us Ruby. Come on.
Yeah. So Ruby has. This sketch for us. So that's a method, a lambda, and then part.
If you sketch it, it runs.
Right. So I'll cover this case last.
Okay.
So in Ruby, you have like 1, 2, 3 map.
There's the
That's like
object orientation showing up here. That is a method on class.
this is
Everything is an object.
yeah. So this is like the anonymous function case.
So that's the lambda.
Yeah, that's the lambda. In Ruby, it's called. So yeah, you can consider that as a lambda. It's actually a bit different. So blocks and lambdas are a little bit different because of the way return maps. So return is different in a regular block versus in a lambda, but for this case, it's the same. I can do the same thing over here as so that's syntax.
So that backslash
Yeah, I think this also works. Is that right? Yeah, but something like that doesn't new syntax where you don't actually say lambda, you say
Actually, it looks a bit like your Haskell lambda, by the way. It's backslash x arrow.
I forget the syntax, but it's something similar actually.
It might be. Now I'm trying on my childhood memories of Ruby. I think it's something like this. I don't know about the brackets.
No, it's something different.
But I think the point to make here, sorry, I think that's just here. But the thing in Ruby is if you the lambda is transformed into an object kind of thing in its props. So in Ruby, so lambda is everything is not a lambda. Lambda is
Yeah, sorry. I had to put that and to.
there we go.
That's pretty much similar like Groovy, where you
Yeah.
have an ampersand where you convert it.
So if you want to do it on the, for example, I haven't converted the square method, right? That won't work. If I put
Okay.
because if I put square over here,
Yeah.
it takes element and it will call that element dot square, which doesn't exist. But I mean, if you really want to muck around, you can basically in Ruby do. Let's see. Oh, sorry. Actually, it's very. Now this is getting very heavy. Because so yeah, in Ruby typically you do it if you are within the same class, then you can take this method and put an and it will be converted to a lambda. But here doesn't it doesn't make sense because then have to put the square method inside the number class, which you can do in Ruby. You can just open up an existing class and modify it, which is what I'm doing over here. But not very idiomatic.
So a method always sits on some kind of object. Even if you define it on the main object, it always needs a container like this.
Yes. In Ruby, a method itself is not an object. The way to think of it is objects are like opaque spheres, and methods are just windows. So the holes through which you do stuff with the object. The holes themselves are not objects; they're just absence of a cover. So you can create a method object which wraps that hole and pass it around, but that's very different from a method itself. A method is not a first class object.
Pretty much Ruby always Scala.
So, I think at this point now, thanks, Inja. At this point, just before we go into exercise, we do an exercise with lambdas because we've gone on about lambdas, but who cares about lambdas? Why should you care? What's the point of it really? And so hopefully with the exercise we can show one of the many things we can do. But just before we go into that, I just wanted to finally say, when you choose your functional language, and if you want to know if language is functional, write a lambda and see how easy it is and how fundamental it is. And that will already give you an idea of how rocky the road is going to be from a functional point of view. Okay, so let's do an exercise. Maybe you can phrase it for us, the timer, timer example.
Sure, so let me pull that out. So basically, the exercise, I'll just phrase it. It's a very simple one. What we want to do is write a function that times the other function. So we use it for performance measurements, right? Normally. So let's say if I have a method called long computation, and I want to know how much it ran for. So probably I would how do I make use of lambdas to measure long computation?
So write us a non-lambda example.
Oh, okay. So let me do that here. I'm just gonna write a non-lambda example. Let's say we have a long computation. Very simple. I'll just say system dot what was it? System dot.
It's pseudocode. You probably want to capture that current time.
Yes.
And then
Yeah. So this is in procedural or whatever way. Now, how do I use lambdas?
And now you do it for another. If you want to do it for another method, you're going to have to repeat yourself. So you want to time all these things, but you want to say, I want to time it now. You don't want to wire it into. And so for instance, in Java, if you've ever done aspect-oriented programming, this is where, in an object-oriented way, you have to step into aspect orientation and cross-cut this concern into all the methods that we want. But let's see how we can do it just with lambdas. And so you've got it. So here's the exercise. You've got a long compute method. It's already written. And you want to, and you can't edit it. You cannot change. So I wrote it. You cannot change it. It's in the source file that you can't play. And you must time it. How do you do that? So think a bit about it. Pick your poison, whatever language you like. you do Java, you'll be here till tomorrow. Go for something with the lambdas. And then we compare notes.
How does that sound?
And, you know, fire off questions if it makes absolutely no sense. Ask a question. I'm gonna sketch
Sure.
something a bit here.
Yeah.
Maybe just clarify it a bit. So I've got this. We've got some function that presumably does something that takes a while, and it returns something. And I want you to give me a function that does that, but that also times it. And so here's the $1 million clue.
I think we should leave there. Leave it there. So should we time this for 10 minutes?
Yeah.
Should we time this for 10 minutes? Yeah. And you can pick your partners if you want to pair. I mean, perfectly okay to pair, and I think that would help actually. You know. Yes.
Just in terms of how you could use it. Now, if I do this, maybe I give away too much. I'm going to show you.
Feel free to assume that you're having a single argument function. Right now, feel free to assume that's a single argument function. You can assume, I'll just put the assumption here. Because, we need to tell that probably. Feel free to assume whether it's a single argument function. Because when you call back,
Yeah.
so there's
Even no.
no argument is the best.
So you can make a long complete function that it takes no arguments.
Let's be simplistic here. We'll say no argument function. Yeah. Reflection. You do it without reflection. You don't need reflection for this.